Hello, everybody. I'm Satya Malik, and I'm the CEO of OpenCV.org.
I'm Brandon Gilles, the founder and CEO of Luxonis.
At OpenCV, we produce the biggest computer vision library in the world with over 2,500 algorithms and more than 1 million downloads per week. We are so excited to be here, and today we are going to talk about OpenCV AI Kit. Since last year or the year before that, we have grown beyond the OpenCV library. We now create cutting-edge courses for the masses. We have cutting-edge hardware for edge AI. And today we are going to talk about OpenCV AI Kit, which raised $1.35 million during our Kickstarter campaign. And this is the best platform for spatial AI. And with me is Brandon Gilles, who is the chief architect of Oak. This beautiful device was designed primarily by him and his team.
So we started on this mission because we were trying to solve a life safety problem. It required the combination of depth perception, AI, computer vision functions, high resolution, high frame rate on a small device. And we found that those combinations were insanely powerful. It's like a cheat mode for interacting with the world with real-time perception and interaction with the world. But we also found that there was no way to do that if you wanted to make something small. If you were building a big robot, you could buy a depth camera and an AI processor and a computer and write your own pipeline. But you couldn't build a small device. And I'm actually using that device to record this video right now. And so we searched desperately to see if someone was building that. The chipset had come out, the Myriad X from Intel, but there was no actionable way to use that. So we decided, okay, we're going to have to build the platform. And that's what the OpenCV AI Kit is all about, built on Depth AI. And it's actually a whole collection of open source hardware, software, and firmware that allows you to integrate this into closed source projects or open source projects or what have you, with the whole goal being that you can prototype really quickly and easily, like in a day, and then you can take that to production, whether it's a closed source project or an open source project, because it's MIT permissively licensed.
And I also like the fact that this is probably one of the few devices in the market, certainly at this price, probably the only one which can do two important things of human visual perception. First of all, it does visual perception using neural inference. Basically, it runs a neural network to simulate, to tell, what things are in front of you, right? So it could say, if you have an object detector, you could say that, there is a dog in front of you. But it also has depth perception, and all of these are done in real time. So you can also say, there is a dog 5 feet in front of you, not just that there is a dog in front of you. So that creates this human-like capability, which is very unique. There's a reason we have two eyes, and there's a reason we have color vision, etc. So I really like the fact that OpenCV AI Kit with depth brings all these elements of human visual perception into play so that you can solve a lot of real-world problems with this.
So the whole idea, like you were talking about, is to mimic human-like perception. So in our eyes, we have two eyes. This has three. So it begs the question, why does this have three cameras in it instead of two? So humans actually have two grayscale and two color in the same eye. They're co-located. So the rods are grayscale, and the cones
are for color. Yes.
But fantastic. That's easy to remember with the alliteration. So with electronics, there's actually a disadvantage if you co-locate color with grayscale. You get better motion estimation, you get better depth perception with grayscale, and they're more sensitive. So just like in human eyes, grayscale is for night vision, it's for depth perception, it's for motion detection, and that's what these are here. But the color is separate because there's this trade if you put color for depth when you're doing electronics, because you have this bayering layer. Imagine it's like stained glass. So you're losing information. But color is very important. So these are global shutter grayscale, which gives you depth perception, feature tracking, and so forth. And then this is a 12 megapixel rolling shutter color, which is then useful if there are specific features you want to zoom into, or say in agriculture applications, knowing ripeness, color is very important. So yeah, this is This device, relatively small. There's the overall size.
I like to call it the Ferrari of edge AI devices. It has so many high-end components like a 4K camera and even the depth camera. It's very high resolution, 1280 by 800. Now let's move on to some of the applications. Brandon is going to show us a demo of what this device is capable of doing. And frankly, we got a lot of inspiration from OpenCV AI competition. This is a competition which is currently underway. There were about 1,400 submissions that we got for this competition in the prelims, and now about 250 teams consisting of about 1,000 people are participating in this competition, which is sponsored by Microsoft and Intel. And this is the biggest spatial AI competition in the world with over $400,000 in prizes.
I'm going to show a demo from Cordic Technology. So they've produced weekly examples of what you can do with the device. And this is one of the powers of open sourcing this, right? And in building this architecture where folks can discover it and do their own things. I don't think he's asked us a single question. and every week we get some really cool thing that we hadn't really thought of that you could do. So this example shows running a variety of multi-stage things to control a robot. So he's doing hand detections. The first stage is he's doing palm detection, and I'm going to mess this up. I think it's called like palmar or dorsal is like the term. So is the palm facing you or is the back of the hand facing you? So you can see here when he does the dorsal, I think it's called palmar or dorsal, then he goes like this, then the thing will move closer to him. When he puts his hand closer, so another stage is doing depth perception on the surface of his hand. So when his hand gets to a certain threshold, it can maintain a distance. And this same competition entrant, phase 1 winner, also did one with his face. So it'll maintain a certain distance from his face, and he did a stranger danger one. And then he's running another neural network off of that to do American Sign Language translation. So not only is he controlling the robot, but he could give it commands or have it automatically translate for him. So this one was really satisfying to watch. And my favorite thing about the competition is there's so many things that I just wouldn't have thought of. And when you get this many smart minds thinking on it, and then have this technology, they can explore this pretty autonomously. And so it's really satisfying to see what comes out of it.
Yeah, and one of the key things that we had decided when we started working on the various aspects was that it should be very easy for people to adopt, right? Our user that we thought in our minds was it has to be easy for any Python developer to pick up this device and start coding for this device. And without any knowledge of AI, without any knowledge of edge AI hardware, nothing. So we took it on ourselves to create the tutorials, which were extremely easy, the installation, which was extremely easy. So the installation takes just 30 seconds, and then we have these tutorials. We have these community members who are adding more and more to the tutorial. And we also have a free course that goes with this device. It's an easy to use solution for people who are just starting out in AI.
And to talk to that a little bit, like when I was prototyping the first solution, I was compiling all sorts of libraries together on a Raspberry Pi, and then training on a computer that I had built and so forth. And there was so much just library work to get things working. And our objective with this is to make it so someone who doesn't have all the answers yet, but is pretty convinced this is a doable thing in their industry. So on the website here for Depth AI, which is the OD model and a slew of others we can share later, it shows all sorts of applications. So this gaze application is an interesting one where it's doing a multi-stage network that does face detection. And then after face detection, it's doing head pose estimation. And after that, it's doing landmark recognition and then eye pose recognition. So what this allows someone to build is, say, an impaired assistance device. So say you're in a wheelchair or something like that, you're recovering, or where you don't have use of some of your limbs, you could actually use this to control things because it can perceive where you're looking in physical space. And as this shows here, it knows the head pose, knows your eye pose, it knows where you physically are. And so then it can get in physical coordinates what you're looking at, and you can give commands, for example. This is another community member from the competition is doing pose estimation. And so this competition entrant made this example that runs Blaze pose on the device to give you three-dimensional position. And then another member of the community saw that, said, well, this is really neat, and actually made a home workout assistant with it. So here it is showing the reps of him lifting weights, and it's counting on the little robot. It's kind of hard to see, but he's actually counting the number of reps on the robot. And then he's doing a whole variety of other exercises here, like push-ups, and it's showing his state, and then it can actually critique how you're doing the exercises as well. So it's really satisfying to see, one, that this was doable, and these were done within a week, right? There wasn't a big effort. They didn't have to recompile all this stuff. It just works. And so it allows you to be creative and solve problems that are at the level of like the interesting part, rather than like fighting a library, which is what I did a ton of work on it. And I feel like a lot of folks who work in the AI and CV space right now, that's what you're usually doing, is fighting a library. And so all our work together here, OpenCV, Lexanis, and then the community at large, is to make it so you can get to work on the things that actually matter and the cool thing that you're trying to accomplish. And that's what really inspired us, rather than all the lower layer stuff and optimization. We've done all that for you.
I love it how much the community has contributed to our effort so far, and it's also the all kinds of not just application level surprises that there are these applications. For example, in the competition, somebody is building an application that will prevent trains to collide with animals like elephants. People are also creating applications for removing garbage from ocean floor, etc., or even the beach. So not only that level of excitement, but there is also the technical excitement where people are building plugins like the Unity plugin. People are integrating it with drones and robots, etc., and open sourcing it again. So that's really fascinating. Almost feel like there's a revolution going on, and we are contributing to that.
Yeah, it's quite satisfying to see all the different applications coming together, and then what you can do with it when it is open source in these ways. So we have folks that are building custom hardware with it. We have folks that are doing custom integration, like the Unity integration. And actually, I'm sharing my screen here where in the Unity integration, to show that it's working, he did a face tracker, and he's actually flying a flight simulator. And then we had another entrant that saw that and said, all right, I'm the one up that, and actually flew his quadcopter by tracking. So he used hand signals to actually fly the quadcopter, and to the idea of this isn't just marketing stuff. So it's really satisfying to see the permutations here from folks doing hardware integration. So we have a whole open source effort now happening in KiCad or KiCad, I'm not sure how to pronounce it, on the hardware, and then also on the Altium side. Then we've got firmware things that are being put together, say with micro ROS, and then we've got software integration, say with the whole ROS community, and robots driving themselves and following you and following your commands, which is a life dream of mine. When I was a kid, I wondered if that would be possible. So it's incredibly satisfying to see us being a part of that actually coming to reality.
From our side also, what we did was we wanted to create a model zoo where it is very easy for people to just see the performance of the models, and they know that this thing is going to work on OpenCV AI Kit. That website is called modelplace.ai, where some of the models, 20 right now, they are available for OD, and this is by far the simplest way to get the models on OD, and we will keep expanding. We are also working with other community members to add their models onto this model zoo as well. And with competitions like the one that we are running right now, a lot of folks are also getting free Azure credits, etc., so they can train their own model. As a technical summary, Brandon, there are a few use cases where OD is the best solution out there. It's not good for everything, all AI solutions, but for certain cases, it is the best solution out there. Could you explain what are those criteria we should be looking at?
Yeah, absolutely. So where it's most useful is when you're actually trying to make something that's a product or product-like. So it's relatively small. You need it to be embedded. To contrast, not embedded is server farm or the cloud. Then there's edge, which is a relatively small device. But a good example of embedded is making smart glasses, right? that can help someone with visual impairments to know, is there a vehicle on the road? Is it at their trajectory? So that's embedded, small, relatively low power. You can productize around it, this sort of level. Then the next aspect is performant. So there's a lot of embedded systems out there for a variety of applications, and there are embedded AI and CV applications. But so far, they've been mainly intended for applications that are relatively low frame rate and relatively low resolution. So the performant aspect is what I mean there. So this is embedded, so you can put it in some relatively small device, but it supports up to 4 cameras. It can handle up to 20 megapixels at 30 frames a second, or one 12 megapixel, another 12 megapixel, a couple 1 megapixel, and it can run complicated networks in real time. So that's the performant aspect. Whereas a lot of embedded solutions are intended for simpler use cases where is there a person in the scene, right? Whereas this is there a person in the scene? Where are they? What are they doing? Where are their hands? What is the trajectory of their hand? So complicated high frame rate stuff. The other aspect is then spatial. So if you need spatial information, that's where this excels, right? Where is the thing in physical space, not just in an image, but where is it, physically in a room or, in a field or flying? And then AI, of course, that's the key enabling technology of this whole boom to make sense of that information. So depth information has been around for a long time for mapping purposes, making maps of rooms and so forth. But it's the AI is what allows you to go from, it's not just a 3D picture a human can look at, but a computer making sense of that 3D information, this embedded system making sense of it. And then the CV aspect. In a lot of cases, when you have, say, a dedicated AI accelerator, it can fall apart when you're trying to make a small product because you don't have fast enough CV acceleration. So those are the 5 things. If you need to embed it into something small, if you need it to be high resolution, high frame rate, if you need spatial information, if you need AI and you need CV. So it sounds like a lot of things. It's 5 things. But what it boils down to is human-like perception on an embedded system, because that's what our eyes and the occipital lobe in our brain is doing, is those things that I described, not necessarily embedded, right? And so it's for these problems where you'd love to put a human there, but maybe it's 80 degrees Celsius and they need to fit in something this big and it's 2,000 feet underwater, right? Not very practical to put a human. And there's so many applications where, were that a capability, you can solve problems that were just kind of like science fiction before. And so it's that human-like perception, but it's something that's this big. And so that's the real game changer here, and where this kit is most valuable. If you're trying to build something big or a lab prototype, potentially this is useful too. Just plug it in and it works. But the real value is then when you want to transition to this kind of big wired together thing to a product like prototype and then an actual small product. So we're coming to the end of the show. One thing I'd like to do is thank Intel and Microsoft out of this. So we're standing on the shoulders of giants on all these tools, right? So it's this huge collaborative effort. And there are 2 things in particular. Intel, of course, with the chip on which all of this is built, but importantly, OpenVINO. So OpenVINO is what allows you to take all these mature and really powerful networks that you see out there, like the pose estimation or face mapping or strawberry picking, any of these networks, and do the optimization for this hardware so it can run real-time performantly and accurately. So go download OpenVINO, check it out. It's extremely powerful. And then I'd also like to thank both Intel and Microsoft for all they've done to promote the OpenCV AI Kit with helping with the Kickstarter, helping with these competitions, helping to get the word out, this video, but then also with Microsoft, all the tools and ecosystem that are there to help you train models, deploy models, and then also refine those models to get the information back, and then even getting data back, say with Azure IoT. So these embedded devices, getting metadata back out to the cloud. So I'd like to give that acknowledgement of how many tools are coming together around this device, which are then what make it useful, right? Without the AI aspect, it's not useful. That's the whole crux of the device. And then without the conversion and optimization, you don't get the performance necessary for a lot of these applications. So it's that fusion of OpenVINO, Azure training, and then the capability to combine that all tightly on device to bring it all together so you can realize these real-time products that I think can make a huge impact on the world.
Thank you so much, Brandon. And I would like to thank our sponsors, Microsoft and Intel as well. They have been a great partner. And I would like to conclude by talking to the developers directly. We are engineers as well, and we like building things. And we are doing something really awesome. We are literally stepping into the spatial AI revolution, and we want your support, your help, and come to OpenCV and collaborate with us. Thank you.